Welcome to the first episode of this bio-inspired engineering series. Today we're going to talk about bugs and how they can inspire the design of efficient flying vehicles. Insects have been buzzing around Earth for over 325 million years. The Wright brothers invented the airplane and achieved the first manned flight just over a century ago. It goes without saying that natural flyers have far more experience flying than any human civilization. We're joined by Alexander Gehrke, a doctoral student at Unfold EPFL. He's currently trying to uncover the secrets of high-efficiency flapping wing flight. Hi Alex, thank you for joining us. How's it going?
Hey Seb, I'm doing great. Thanks for having me on the show.
Oh, it's a pleasure, it's a pleasure. So why don't you tell us a little bit what brought you into the world of bio-inspired flights?
So I've always been inspired by these natural flyers. They show great abilities when it comes to flying around and navigating. We have them around us all the time. And when I studied mechanical engineering, I got the tools to study aerodynamics, and I saw the study of flapping wing flyers as a great merge of these two interests.
Okay, that's interesting. And so I can imagine it's really challenging for you to observe these tiny little insects flying, let alone take measurements. So what way do you have around this problem?
That's a good point. It's really difficult to observe on the natural flyers all these phenomena going on, let alone measure like the force or lift they might create. So to get better insights in their flight dynamics, we designed some experiments where we recreate the natural flight on a mechanical device, which then allows us to not only put the insect directly in the frame we wanted to, but also to measure its performance directly on the wing.
Okay, that's nice. So you've built a machine that flies like an insect.
Right.
And how did you actually teach your machine to move the way an insect does?
So every natural flyer has their own kinematics to fly, which are adapted to fit their wing and maybe some other biological pressure they had during evolution. And so it's only natural that our mechanical device has its own optimal kinematics to achieve flight. To find these kinematics, we use a genetic algorithm, which works similar to the genetics in nature, that it tries different kinematics. Then you see how they are doing, how much lift they are producing, how efficient they are. And then with generation to generation, the performance improves until we find some kinematics which are optimal for our system, for example.
Wow, that sounds awfully complicated and very intelligent. How do you see this flapping wing flight change the landscape of air transportation?
Well, I think for most transport applications, these natural flyers are not necessarily geared for where our already existing technology fits really well. However, the more you reduce the overall size of the air vehicle, we noticed that the flapping wing flyer are much more efficient at producing lift to stay in flight. So I think the most natural application we can think of would be to have very tiny scale flying robots which could undergo missions like search and rescue, or maybe monitor the environment, say in a forest where it's very difficult to navigate with a large scale air vehicle.
Okay. Do you think it would be possible to make me a personal flying machine that would flap?
We could think about doing that indeed and designing something. But I think that would not be the first application that comes to mind.
It's a shame for me, but it makes sense from an engineering point of view.
Right.
Okay, well, thank you a lot for joining us. Thanks for being on the show.
My pleasure.
And thank you for watching this video. We hope you've enjoyed it. Stay in tune if you're interested in our bio-inspired engineering series. In next week's episode, Mrudula and I will be discussing how the scallop may hold the secret to autonomous marine exploration and rescue. See you then.